Good day. My name is Dan Bogdanov, and I am the Chief Scientific Officer in Cybernetica. Cybernetica's business has always been to bring new technologies from fundamental research to practice, and recently we have turned our eyes on data, one of the modern resources that governments and industries want to use. However, the use of such data comes with restrictions, whether regulatory or ones stemming from distrust. Can you actually put that file on that cloud? Can you actually share that table with that person? Such stress, such distress whenever you want to launch a service or just to collaborate with a fellow human being. So fortunately, technology is giving us solutions. PET stands for Privacy Enhancing Technologies, and today we will tell you a little bit about a few of them that we have been working on recently. Most notably, if you are an organization that is launching data-driven services of any kind, whether a mobile app that takes care of people's wellness, or a social network, or something that uses biometrics, or something that works with a car or a smart device, then somewhere in that process you are using personal data or something that could be construed as personal data. So today we will tell you about what are the legal meanings of anonymous and pseudonymous. We are going to tell you about the specific technology called synthetic data generation that is rather new, that we have been working on for a while now. And we will be telling you about how you could take the opportunity and start using such technologies in your systems and services. This is becoming important as we increasingly use infrastructure across borders. A lot of the cloud providers may be in other territories where the same regulations do not exactly apply. Figuring out which data you can send to which partners is a problem even for a small company. So if you have lots of data in a large company, that can be even worse. Often a false balance is set, the privacy usability balance. Whether you have privacy or can you actually use the data. We would like to take this a little bit more granular today. Instead of thinking whether or not to work with data, we should be thinking on what are the complexity that we are willing to endure to process it, and what is the utility that we want out of the data. We are very much pro using data in your new services. What we want to teach you today and what we want to work with you on is how to do that in a protective and a secure way. So the balances that we will be explaining today are especially the ones related to complexity. We know that some of these new technologies might seem black magic, might seem impossibly hard. We're here to tell you that this isn't so. We can make a lot of this work for you. There are already companies and governments in the world who are doing so, and privacy-enhancing technologies are making their way in the world. The second aspect, obviously, is to understand the actual utility you want out of the data. Whether you want to go back to the individual afterwards, whether you want to build an AI model, and whether you want to just do something with statistics. It's all slightly different. If you want to disclose a data set, if you want to give the data set out, you may use different technologies from when you just want to calculate something from data you've collected from different people, or their mobile phones, or their smart toasters, or whatever. So, today we will be taking you on a trip to teach you about privacy-enhancing technologies. And the first to do so will be Triin, who will tell you a little bit about the legal aspects, as they are rather fundamental to a lot that we will be talking about.
My name is Triin Siil, and I'm a lawyer by profession. Here in Cybernetica, I work as a privacy engineering consultant, helping our engineers understand and design suitable solutions for different kinds of privacy problems. And my job here today is tell you about the difference between anonymization and pseudonymization. But before I can do that, I have to explain a little bit what is personal data and what is anonymous data, and why it matters in the legal sense. Well, first of all, I'm now located in the European Union, in Estonia, and this is the legal domain where I'm mainly educated in. So this is the experience and laws that I can share with you. So just a reminder, today I will be talking about the data protection laws in the European Union. But as it happens, the laws in Europe have also become kind of thing to look forward to, or look up to even sometimes, or kind of a standard for data protection laws all around the world. So I hope this talk today is relevant to different jurisdictions, wherever you are joining us from. And the agenda for today consists of two parts. So first of all, I will tell you about what is personal data and how it differs from anonymous information. And in the second part, I will tell you more about the processing of personal data and how pseudonymization and anonymization are types of processing. I will also tell you about the legal implications of both and why it matters to talk clearly about personal and anonymous data and defining them correctly in the legal sense as well. So let's get to it. First of all, personal data versus anonymous information. A quick reminder to those of you who are not fully fluent in European data protection law. We have laws in effect in three different levels in the data protection field in the European Union. The first and the highest level is the EU Charter of Fundamental Rights. And it's interesting to note that there are two different kinds of fundamental rights enshrined in this charter. So first of all is the right to respect for private and family life, home and communications, which is stipulated in Article 7. But second of all, there is also the right to protection of data protection in Article 8, which is about fair processing, specified purposes for processing, legal basis, right of access, and right of rectification. And it does make sense to differentiate between them, because in many parts of the world, there is no such thing as a separate right to protection of data protection. So in European Union, we are quite in a special position. We are not only trying to give individuals control over their private and family life, but we are also trying to protect their principal right to fair processing. And these two different aspects of privacy and data protection are very important for Europeans. The second level of data protection law comes from the General Data Protection Regulation, which is a directly applicable legal act all over the European Union, no matter which member state you are from. And this act regulates many aspects, starting with the general provisions, including definitions, principles, rights of the data subject, and ending with specific data processing situations like employment law, contracts, and so on. But today I won't be covering all of the GDPR. I will be focusing mainly on the two first points, talking about some of the definitions and principles and some of the norms in those chapters. And last but not least, we have also the member state level for data protection law, which is the national data protection law. And this is the kind of the lowest and closest level to practical life. This is where the member states have made specifications or even restrictions to some of the norms in the GDPR, which have been permitted by GDPR. So for example, in Estonia, those specifications and restrictions are foreseen in the Personal Data Protection Act, whereas in Germany, which is a federal state, member state country, in the federal level, they have the Bundesstaats- and Schutzgesetz, but in state law, the level, they have separate data protection acts per each federal state as well. So each member state has their own unique approach to data protection as well. Now, coming back to the GDPR level, GDPR is where the key terms in data protection law in Europe are determined. And the first key term is personal data, which is stipulated in Article 4.1 of the GDPR. And it's quite simple when you read it. It's defined as any information relating to a data subject. And next to personal data, data subject is also defined. Data subject is someone who is an identified or identifiable natural person. And it's even specified further that identifier natural person can be one who is either identified directly or indirectly, whatever that means. However, in general, we understand, and GDPR understands, identifiability through a reference to a certain identifier, such as our name, maybe our age, maybe our identification number, location data, etc. And it is important to understand what is personal data because GDPR and all of its norms apply only to those kinds of data which can be identified or identifiable. So GDPR doesn't apply to anonymous information. What is that? Well, the only place where GDPR talks about anonymous information is in its recital 26. It mentions the term anonymous information, and it defines it through two conditions. First of all, it is information which does not relate to an identified or identifiable natural person or a data subject. And second of all, it has to be somehow either rendered anonymous in such a manner that the data subject is no longer or is not identifiable. So there's like two options to anonymous information. Either it's anonymous per se, because it doesn't relate to anybody, or it's made anonymous through some kind of process. And in those two cases, GDPR doesn't apply to the end result, the anonymous information or the data that is rendered anonymous successfully. Now, coming to the second part of the presentation, let's talk about processing of personal data and what that means. GDPR defines processing in Article 4.2, and it is defined as any operation or a set of operations which is performed on personal data or on sets of personal data, whether or not by automated means. So even if you have paper documents with your name, identification number, and all kinds of information about you written there, or some kind of a file where this paper is stored, that too can be subject to personal data processing. It doesn't have to be electronic, although we are kind of used to thinking of processing as an electronic procedure. So processing can be basically anything. GDPR mentions that it could be collection of data, recording of data, even structuring of data, storage of data, but also modification of data, erasure of data, or even destruction of data, which is personal. Now, when we talk about pseudonymization, then this term too is mentioned in GDPR in Article 4.5. And it's defined as the processing of personal data in such a manner that the personal data can no longer be attributed to a specific data subject without some use of additional information. And this additional information has to be kept separately and subject to certain technical organizational means to ensure that the personal data are not attributed to a data subject. So the key term here in this definition is additional information. It could be a name, which is either deleted or replaced with some other information. It could be some kind of identifier. But the different options, how pseudonymization could be done technically, will be talked about more in detail in the following presentation. Coming back to recital 26, we see that pseudonymization is a kind of a it is a way how to process personal data, and its result is pseudonymized information. And recital 26 says that even if data is pseudonymized, there is still the chance that through this additional information, the person could still be identified. And this is the reason why we consider pseudonymized information as personal data. Whereas in terms of anonymization, whenever personal data is rendered anonymous, it goes through a type of personal data processing, but the outcome is hopefully non-personal data or anonymized information. But whether it really is anonymized or not depends a certain risk evaluation, which is quite a complex task. So there's never really a guarantee that any kind of anonymization ends up in non-personal or anonymous data in terms of GDPR. And one last thing I want to mention here is that when we talked about personal data versus anonymous data, I mentioned that the legal implication is that in case of personal data, GDPR still applies, but in case of anonymous data, it no longer applies. Then in terms of pseudonymous information, there is an interesting article which has not often been noticed or talked about, and that's the GDPR Article 11, which says that if the controller who processes personal data does no longer require the actual identification of data subjects for its purposes of processing, then it's actually released of the obligation to maintain, acquire, or process this additional information which helps him to identify the persons. So the GDPR basically says that you don't have to keep on maintain information about me if you don't need to identify me in the future. You can basically just delete it. And if the controller can really demonstrate that as a result of either deleting this additional information or otherwise it is not able to identify the data subject, then GDPR Articles 15 to 20 no longer apply, which means that data subject rights, certain amounts of data subject rights are actually kind of given up according to GDPR. And this is hopefully supposed to motivate companies and other processors to make better use of pseudonymization as a data protection measure. But what we mean by pseudonymization in technical terms, this will be now explained in the next presentation by my colleague Liina. I thank you for your attention and I hand over the microphone.
Hi, my name is Liina Kamm. I'm a senior researcher, and my research focuses on privacy-preserving data analysis. And part of this is synthetic data generation, which I'm going to tell you about today. So there are different ways of privacy-preservingly analyzing data, and I've listed some of them here. And I will give a short overview of each of these. So pseudonymization, as Triin already mentioned, is basically just removing direct identifiers from datasets. Anonymization is a bit more difficult, and in anonymization, you instead of just removing identifiers, you have to make sure that the data subject is not linkable afterwards to data subject in an anonymized data set. This means that you remove, in addition to removing direct identifiers, you also remove quasi-identifiers, which are groups of identifiers that could identify a person. So let's say that gender doesn't identify a person directly in a data set, gender and age group do not, gender, age group, and education do not. But the more specific you get, the more data attributes you add, the more a person might become unique in the data set. And anonymization works towards making it so that the quasi-identifiers there is no unique person in a data set with respect to quasi-identifiers. Now, with pseudonymization, there is always a way to go back from the pseudonymized dataset to the original dataset. In an anonymized dataset, it should not be possible. Federated statistics is a way of analyzing data so that you don't actually send datasets out to a third party, a trusted third party, but what you do is you send intermediate results. So you're sending basically either some analysis intermediate results. They will be taken to a third party, and the third party will put them together to form unified statistics. Differential privacy is more output privacy. This is meant more for data data releases, so that you can, for each data release, you add some noise so that people will not be uniquely identifiable in the data set. Synthetic data generation we will be talking about in detail a bit later, but right now I will still talk about secure multi-party computation, which requires you to have several parties, as is in the name, multi-party. And here in this method, none of the parties individually will be able to see data subject values. However, they will be able to run protocols that compute data analysis algorithms, so that you will have results without actually no one ever seeing individual values. Fully homomorphic encryption works roughly the same way, only you don't need as many parties. However, fully homomorphic encryption at the moment is not yet feasible for all different algorithms. So but that could change in the future with optimizations and new algorithms being built. And then there are trusted execution environments, which are basically trusted parts in a computer processor. And on the hard disk, the data are kept encrypted. However, they are only opened in the trusted execution environment where the computations are run, and then the results are encrypted again, and they are sent out to result parties who can then decrypt them. Here you put your trust in the processor manufacturer. However, these are also becoming more and more popular nowadays. So all of these methods are different, and all of them have different privacy guarantees, different usability guarantees, and as Dan mentioned, there is always the privacy and usability trade-off. But this trade-off also works with privacy and complexity, privacy and utility. And we can always say that if we work on basically a data set without doing anything to it, then we have full utility of the data set. We can find all information in the data set. We are not taking anything away. On the other hand, on the other end of the spectrum, we don't do anything with the data. We don't even collect it. Or if we collect it, we just put it away, bury it somewhere, and we don't use it. So those are the extremes on this. So I don't put that on the slide because we actually want to use the data that we collect to get information out of it. But on the other hand, there is really no need to have the identifying attributes in the data set when we're, for instance, trying to find out the age of the group, or the average age of the group, or whatever other statistics. So I've put the let's say next to the extremes on this slide, and so the privacy risk in using pseudonymized data is high, and because you're basically working on just with the IDs removed. And it's really easy to find people in such data sets, because especially if it's a group you might know, if it's a group that is from a small a sample from a very small group, for instance. So you might find people that you're really not looking for in there, just find them accidentally. Or if you make a release of this data set and put it up somewhere, then there will definitely be people who will be looking for other people in these data sets. Now, for working on encrypted or secret shared data, so here the privacy risk is low, because you never see individual values, but what you can get is information out of the data. Okay, but then why not use only encrypted or secret shared data? Well, here comes the trade-off, because using pseudonymized data is very easy. You just get a cross table and you do your analysis, or you get a relational data set and you do your analysis, and that's it. However, with encrypted or secret share data, first you need to deploy it, you need to set it up, you need to have several parties, or you need to have someone who knows how this works. You need to have data analysts who are willing to actually use or analyze data in a way that they don't see individual values. And this is very difficult for people who are used to looking at the data set in a sense that they actually look at the cross table and see what's in there and then start doing. We say that it is actually possible to get an overview or to kind of look at the data set without actually seeing individual values, but still this is a difficult learning curve for people. So this means that it has high complexity. And of course, as with complexity, the frequency of use is similar to complexity, that it's very commonly used. Pseudonymized data sets are very commonly used, whereas encrypted or secret shared data are rarely used. Now, I made this kind of graph where I've tried to position the technologies on a two-dimensional graph. And it's basically high privacy risk, low privacy risk, and then the complexity of use on the other axis. However, what is missing from this is the third dimension, which is utility. So now you can see that it's where it is really good to be on this graph is to be on the lower right side, so where synthetic data actually is, which means that you have low privacy risk and it's fairly easy to use. Now, pseudonymization is very simple to use, as we've talked about already. Anonymization is more complex. There are algorithms to help you work on this. There are tools that do this for you, so you don't have to do anything yourself. So it's fairly easy to use, but it still carries a high privacy risk. Federated learning is a bit more complicated, and it still carries high privacy risk because the intermediate values you send can tell people a lot about your data. Now, and this is also federated statistics and federated learning. Differential privacy is already more complicated because you have to find the right amount of noise to add. Trusted execution environments are rather complicated to use. And homomorphic encryption, secure multi-party computation, whereas the privacy risk is low, they are really complicated to use on this scale. Now, synthetic data luckily falls on the easy to use and to deploy and on a lower privacy risk scale. However, on the utility scale, we are not sure, because you might get good utility out of your synthetic data, or you might not. And also, not all of these technologies are relevant for or useful for all use cases. And this is very important to keep in mind, because if you have total control over your data, you have consent from users to use their data, then it doesn't really make sense for you to start using very high privacy enhancing technology, because you already have a right to use the data to analyze the data. Then it makes sense to use. Well, I would still recommend using pseudonymized data, not using like fully personalized data sets, but still, it's a thing that you have a right to do. So you might as well work on that. And again, as I said, then differential privacy is more of a data release. Method, and as is synthetic data. So if you have right to analyze your own data, then it doesn't make sense for you to synthesize data and then work on that, because that is like you're building. You have a box and you're building a box based on your box, and then you're using the other box. So you're not using your box. So it's kind of. Synthetic data is meant more for data releases. You put you either give it to someone else to use, or you do a data. Let's say you put them up like open data, because, and here is the good part of synthetic data generation. Synthetic data have been generated from real data and have the same statistical properties as real data, but they are not real data. And again, this has a small caveat. This depends on the strength of the synthesis algorithm. And well, from the perspective of legislation and data protection, it's not yet binding. So in Europe, we still don't know what synthetic data is in the sense of GDPR. As there is no way of linking anyone back from the synthesized data set to the original data, then we can't really say that. We should be able to say that it's anonymization. However, we still need a jury's still out on that, let's say. So what does it mean that they have been generated from real data and have the same statistical properties as real data? So there are different ways of synthesizing data, because data can be structured, like, for instance, relational databases. Data can be unstructured texts, like doctor's notes or transcripts. Data can be images, videos, audio, or virtual environments. And now you can synthesize either based on real data sets, not based on real data, or using a hybrid of the two. And I'm sure many of you who've ever dealt with data have already synthesized data, because synthesizing data is basically making up 10 people from the top of your head. You know some rules, and you're going to use those rules. And those rules are basically like, okay, I know that there is a difference between, like there is a difference in height and weight of, let's say, grown-ups and children. So if I make a data set of children, I will have them be shorter and younger. And when I make a data set of adults, I will make them be over 18 and have kind of a correlation between their heights and weights. So this is already data synthesis. However, what we're talking about is data synthesis using real data. And here you have, let's say, an example data set. I would recommend using because you don't really need the identifiers to synthesize data. So we'll say that we're using pseudonymized data set. What you do is you build a machine learning model based on your existing data that retains all of the connections, the statistical connections in your data set, and then you will synthesize data based on this model. And that's it. You get a new data set. It is randomly generated data, but it has the same relationships within the data set. So if you do a distribution of the data, it should be relatively the same as before. However, no single individual is represented in the end data set. A good example of this is a website, this person does not exist. This is using a generative adversarial network. And here, basically, what is done is the neural network has been trained on a huge data set of pictures of people, and now it is generating people. And for us, for a human being, it is easy to see that these people look like people, but they are not really a person. So if I give you like tabular data, as I did before, then those tabular data for you, you can't, if there's like 1,000 of them, you can't really tell the difference whether it's like, whether you can see whether it is the same person or not. But here, if we give you the data set of people that they're generated from and these generated people, then a person can see whether it's the same kind of person or not here. So whether it is generated or whether it's a real person. So data synthesis steps. So imagine that you are a company that wants to synthesize data, and what you have this real data set. So what you do is you build a model. You synthesize the data, and you get a synthetic data set. And now, this is not the end of the process yet. You still have to see whether you can actually use the data set. And for that, you want the data set to be as close to in relationships between data, to be as close to the original as possible. However, you also want to make sure that no individuals have carried over from the original data set. So what you do is you synthesize the data set, and then you take the original data set and you take the synthetic data set, and you put them, you compare them, and you get the utility assessment. If it's not good enough, you synthesize again. You do the same thing again. You compare the two data sets. You see, okay, now the utility is good enough. And then you can also, also output the utility report, basically. And then, but now you have this really this data set with really good utility. It's really close to your original data set, and you could even maybe do machine learning on it. Maybe not, but maybe you could already do some other, like give it to a data analysis or a data science company and have them do complex machine learning for you. However, you still would have to do the privacy assessment first, because then you take the synthetic data set and you take the real data set and you compare those two. And now you will get the privacy assessment of whether the people are, whether there is a unique person who was in the original data set represented in the synthetic data set. And this is also very important place. Now, depending on like the utility and privacy trade-off, let's say, depends on what you want the data to be used for. So you can use the data for, as I said, if you want to have a data science company perform machine learning analysis for you, then you can give them the, you don't have the right to actually give out your data, then giving them your synthesized data set might be the answer. And then you would need high utility from the data, because you would need them to be able to actually carry out the machine learning algorithm or machine learning methods. However, if you're doing this for, let's say, software testing, so you're having a software system built, and you want the company who's building your software system to test on data that looks like real data and has some corner cases in it. Then for that, it's actually a very good way of you just synthesize the data. You don't need it to be high utility. You just need it to be close enough, and then you can have like higher privacy guarantees, so that less information is carried over, but you don't get as good utility. And so this is the trade-off that's there. So with respect to other privacy enhancing technologies, then if we compare data synthesis to pseudonymization, then pseudonymization has worse privacy guarantees because it's still just basically real data, and data subjects could still be identifiable. If we're talking about anonymization or de-identification, then there data utility is already questionable, because in anonymization you're basically leaving out all of the unique corner cases. So you might lose groups of people. You might lose let's say not even people with PhD degrees, but you might even lose people who have master's degrees. So that could be an issue. Whereas when you're using data synthesis, then those corner cases stay there, because you still have enough data to generate these random people, and you check that they're not the same as the original people, so you could still have them be in the data set. And now if we compare it to secure multi-party computation, if you recall, this has the best privacy guarantees, then secure multi-party computation is more complex to understand, set up and run. It requires multiple parties, and it could be slower in performance than data synthesis. However, secure multi-party computation has better utility, because you're working on real data. You're not, because the synthesized data set still loses some information because it's not the real data set. It's similar and it gets the job done, but it doesn't have the exact, if you want really precise results, then secure multi-party computation is your go-to thing. And well, as I said, then secure multi-party computation has better privacy guarantees in a sense, because you still can retain, as a computing party, you can still retain control over your data. While when you have the synthetic data set, you're still like just giving it out. You don't know how it's used, where it's put. You have contractual obligations with the one you're giving it to, but you can't really be sure what analyses are run on it. And now Baldur will take over and talk about deployment and solutions of data synthesis. Thank you.
Hi, I'm Baldur from Cybernetica, and my role is to look out on the market and identify problems that customers have. And a lot of our customers have been coming to us and asking for help, that they need to give their data out, for instance, like Liina said, for testing while building a new information system, or even to do some machine learning contests that they have very interesting, either medical or financial data. They would like machine learning specialists to build solutions and models on it, but they cannot give out their own data. So Cybernetica has come up with a couple of solutions that enable to generate data that companies can easily give out without legal implications. And the novelty of all these solutions is that they can also be put up as services where the service provider also does not see the data. So, for instance, imagine a cloud self-service in a local, like European or your country's data server, where you could put in your confidential data and get out data synthesized based on your data. And if you don't like this cloud-based solution, you have restrictions or policies that guard you to have in-house solutions, then it can be also deployed as an in-house solution to generate synthetic data based on real data. We also have helped customers to generate synthetic data without actually depending on original data. That sometimes is useful for either information system testing while building, or even stress testing and benchmarking if the solution is capable to handle the workloads that you plan. One of these projects that we are very proud of, that we did for Eurostat, is a sample solution how to process location data privately. Nearly everybody nowadays have a very smart gadget in our pocket. That's the smartphone. And phones leave traces in the networks of the mobile network operators. This is very useful data also for statistical institutes to do, for instance, tourism analysis, or to estimate the current financial balance of the country, how much tourists bring money in, or how much our people going out take money out of the country. And in this project, we actually proved that it is possible to work with mobile network operator data while preserving the anonymity of the mobile phone users. And in building this solution, we also had to build a synthetic data generator, because the customer's requirement was that no personal data should be processed in the project. And we generated data for like 100 million mobile subscribers moving in the space. So that is like one option, that if you need data to give to your partners, you can talk with us and we help you build a generator and just provide you the data that emulates the process in your information system. For this project, Cybernetica used one of our privacy-preserving technologies, Sherman HI, that is building on Intel SGX trusted execution environments. And as said, the synthetic data generated is one of the first and easiest steps in approaching privacy-preserving techniques and technologies. So I would say that you are all welcome to come and talk with us. We can offer you solutions in solving your privacy problems or getting data about your customers or partners to those that you need to share it with. And now I would like to invite our team here to do the question and answer session with you. Thank you.
Thanks for staying with us. There's a few things yet to be answered, which at least I picked up from the talks that we had. First of all, so let's try to bring it a little bit closer to the listener out there. So what is, in your mind, the best use case for synthetic data generation? And if you could name a sort of a kind of organization that could use it today and how they could use it. And that's, I think, a good question where everybody can have a view. So does anyone want to go first, or do we go in a order?
I can go first.
Please.
We recently had a project that ended at the end of August, where we actually we did data synthesis in trusted execution environments. So it's like using 2 layers of privacy enhancing technologies. However, we also talked to stakeholders. We also talked to different government agencies to find out what their needs would be. And I think from that, what we can take away is that the IT capability of different government organizations, and I think of different companies as well, is different. So if you're an IT company, then for you, you already have a team capable of data synthesis, or well, let's say not data synthesis maybe, but data analysis in a larger degree, and then just getting the knowledge of data synthesis. It would be work. You have to kind of get it to work, but you would be able to do this. And if you're like, for instance, you're outsourcing the data science, usually then just synthesizing the data for the data scientists would be easy to do. But if you don't have any kind of like data science capability, then and then you would have to also buy this as a service, like the data synthesis. But then as well, then it would also be like useful to have the data synthesized for testing, and have the data synthesized for testing by then either do it yourself to have So testing is one, and I would say that data machine learning maybe, but maybe to a lesser degree, because if you're already outsourcing the data synthesis, then you might as well kind of try to outsource the machine learning like immediately, not do it by proxy.
Okay.
And if I may add, we did the project together, and for me as a lawyer, it was quite enlightening to learn that oftentimes before you actually choose the synthesis model or whatever, the machine learning model, you do need to do quite a lot of playing around with the data, getting to know the data, trying to understand what are the general characteristics, what kind of associations you can build, what kind of techniques work, what do not. So I understood that synthetic data can also be very useful for that process where you still are basically choosing your methodology of analysis. You don't yet know what could work, what not. And at the same time, you want to preserve privacy and do as little interventions as possible. So for that, I think synthetic data is an excellent thing to use.
So, but any concrete organizations? Baldur, can you imagine, name 3 organizations you can imagine who would benefit from synthetic data generation?
Oh, I was just trying to protect the names of the organizations. No. Okay, let's go. Tax and Customs has huge amount of very interesting data about people and enterprises, and they are getting hundreds of requests every year to provide data for this and that analysis project. Well, knowing how the analysis companies work, this is what Triin said, that basically there's a huge exploratory phase when the companies are just figuring out, oh, now I have the data, what shall I do with it? This phase can be looked upon as some kind of testing. Basically, it would be very good to use synthetic data for that. And imagine there would be like a competition, not that who does the project, but who comes up with a better model. Then you would have like several competitors, and the actual model would be like the proof, and that you could take in-house, that the companies have built with synthetic data. Then you could take it in-house and run it on actual data. And a lot of privacy problems would be solved with that process. And also the question of sharing your data left and right and waiting when the catastrophe happens would be avoided.
However, you have to note that I think what I forgot to mention was that for synthesizing data and the part where you're making a machine learning model for the synthesis, not based on the not the one part where you're synthesizing the data, but where you're learning from the original data set and making the machine learning model, that is still considered data processing as per GDPR. So that is something that before we can kind of we have to get an understanding that this, similarly to anonymization, actually falls under the needed protection measures of GDPR, so that we are because it is like if you think of this from a pragmatic point of view, then if you think of it, I give up pseudonymized data, which just has my ID code removed and my name removed. Or I give out data that has been synthesized based on the original data set, then it is clear that the synthesized data set it has better privacy guarantees.
Better privacy. So better. What does it mean better? What can I do less with it, or which attacks are impossible? What does better mean here?
So for instance, the first thing what better means is that if we do it properly, we go through the process properly. And again, it depends on each use case. But if we're talking about, for instance, for testing, then you can tone down the utility. It doesn't have to be so much similar to the original data set. Mm-hmm. So you don't have as high utility, but you still have the you still have a similar data set. It might still have some corner cases which might come up and so on, but you can't link it back to the original data. So with pseudonymized data, it is very clear that you have a connection, so you can connect back to the original data set. And this is good, because if you were doing, for instance, like personalized medicine, then if you find some issue with the person, then you might want to tell the doctor to go back to the original, to the original person. Again, ethics has to be considered there, because if it's like a danger of a disease or so, but you might want to set up a group and then just say that, okay, you have these kinds of, these are the pseudonyms for the person who you should actually maybe contact, and maybe do some more blood tests for them, or do some more blood pressure measurements for them, or more often, and so on. So not be like very invasive surgery, but just kind of maybe more protective measures for that.
And that sort of going back is not something you can do on synthetic data? No,
because they're not real data. Mm-hmm. You don't have the person who was in the original data set will not be in the data set. You will do the privacy analysis as was in the lower part of the of the figure, and you will make sure that none of the original data people are in the data set that was generated.
I have one more question, then Baldur, you. But okay. We've been a little bit, we haven't been giving out promises to our listeners about the legal status of synthetic data generation. I understand it's not the time to do that fully. Actually, I've come to understand that it's pretty much impossible for any technology, because you can shoot yourself in the foot with many different weapons if you use them incorrectly. So if you're an organization today and you're thinking, can synthetic data generation solve my problem? Then what's the steps I should go through so I could make claims about privacy or make claims about data protection compliance? What's the best I can do today?
Well, first of all, I think you can never do it in abstract terms.
Mm-hmm.
Synthetic data, is synthetic data anonymization? I think nobody can claim that. Nobody will give you assurance of that. It is always dependent on the actual use case you are deploying, where you have to where you want to use the synthetic data in. So whenever just forget the abstract side and fixate what is the problem you want to solve, what kind of data you want to process there, who are going to be the processors, and what is the end result you want to get to. And once you have that kind of this general business process outlined, then you can start qualifying. What is the input data, what is the output data, how do we get from the input to the output, and also compare if there's any new personal data created in the output when, for example, the output synthetic data might coincidentally include data about actual real people who might have been involved in the initial input data set. So it always depends on the use case. It always depends on the specific deployment, specific processors, and no guarantees for the abstract synthetic data as such. It's very, it doesn't make sense there.
So it's a project.
It's a project-based approach, case by case approch.
Fair enough. So when you undertake that project, so what else should you be doing?
Well, I totally agree with Triin that first you should understand the stakeholders. They're basically like an organization around the use case. You should understand what is being processed for what and how the data should move between the stakeholders. So even if it's synthetic data, maybe you would need it to first sort of run through the pipeline, test it, and then if the pipeline is already tested and secure and all the stakeholders understand their role in processing the data, then you could let the real water in.
Okay, so synthetic data generation helpful, as you mentioned, in exploratory data analysis and building the system before you put the actual data in and you like iron out the wrinkles before.
Yeah. And also every organization has this problem of external developers being involved in building their systems. And it depends on the systems and policies of the organization. For instance, we had, my background is coming from data analysis and data warehousing, and we had an interesting coefficient to that like the complexity of the project, the price of the project depended on that complexity, and when you couldn't access real data, for instance, and there was no synthetic data at that time, we estimated that the complexity was 4. So basically, you had to multiply your effort when you see your data and you do the project, or if you can't get access to real data that has its own wetness and security, interesting properties, then the amount of work that you need to do, especially in testing, is multiplied by 4. And a very curious case that nowadays probably applies to other countries, not Estonia, but before the address register was implemented in Estonia, every information system had their addresses in their own way. And in one analysis project, while we estimated if database-based census is possible in Estonia, we found like 95 different ways of writing one address in one Eastern Estonian town.
That's the name for people's names as well, so that's a known problem indeed. So I guess recently there's been not much recently, for several years now, there has been a hype of digital twins. So one thing I took from here is that it might be that synthetic digital twins might be a nice thing. If you could have a synthetic digital twin of a financial ecosystem, we could test out new fraud detection or anti-money laundering tools for synthetic digital twins on health data. We could let students try their hands on machine learning tools and so on. So there's a lot of promise in education as well, I guess.
Yes, definitely. Because, I remember from the university times and cooperating with the university, getting real interesting data into the hands of data analysts, that was a real problem. And usually you discovered then the early truths about real data. Early data is dirty, real data is dirty, real data has gaps.
Well, as usual. So, to conclude, Going through the pain of doing a synthetic data generation project today will reduce the pain of sharing the synthetic data with researchers or students or other service providers later. So we encourage you to learn the new technology, and we'll be here for you to help you on that path. Thank you.